Welcome, everyone, to TechDaily.ai. Today, we're really digging into something huge, AI in the cloud. It's transforming everything. We'll be unpacking how it's evolving, why securing it is so critical now, and maybe most importantly for many, how to manage those sometimes pretty significant costs. Before we dive in, just want to mention this deep dive is brought to you by Stonefly. They're your trusted advisors for enterprise storage, backup, DR, hyperconverged solutions, VMware, Hyper-V, Proxmox clusters, plus AI servers, the SA365 security appliance, and cloud options. Check out stonefly.com. All right, let's get started. AI isn't niche anymore, is it? It's everywhere, and cloud computing really made that happen. But, with that power comes, well, a lot of new things to worry about. We're going to look at the future of digital risk, how serverless makes AI more accessible, and how to secure those complex AI pipelines.
It really is amazing how fast it's scaled. Cloud platforms, they've genuinely democratized these advanced tools, analytics, decision-making, now accessible to almost anyone. But that widespread use and naturally opens up vulnerability. So yeah, we need to understand both sides, the opportunity and the risk.
Right. So when we talk about AI in the cloud, it sounds almost magical. What are some of the really transformative things this combination unlocks for businesses, for innovation?
Oh, the synergy is immense, absolutely. We're seeing intelligent resource management, really accurate predictive analytics, automated deployment, stuff at a scale we couldn't imagine before. And think about security itself. AI enhances cloud security, Real-time threat detection, anomaly spotting, or user experience. Personalized recommendations, those sophisticated chatbots using natural language processing, it all improves service delivery and often reduces operational costs.
Okay, that makes sense.
Yeah.
Better services, potentially lower costs.
But yeah, it's not all smooth sailing. This integration, it brings challenges. How do we manage just the sheer volume of data? How do we guarantee privacy? And critically, how do we stop bias creeping into these systems? These are huge questions.
You mentioned democratization earlier, and that immediately makes me think serverless. For our listener, how does serverless computing fit into making, that massive scale AI processing more accessible?
Yeah, serverless has been a game changer for democratizing that kind of massive data parallelism. It lets users launch thousands of concurrent functions for big data jobs without worrying about managing servers. You don't need to provision anything really. You can just spin up thousands of virtual CPUs on demand. It lets you run ML algorithms in parallel across terabytes of data stuff that would swamp a single machine.
So the takeaway is it removes a lot of that heavy lifting on the infrastructure side, makes powerful AI accessible even if you're not a cloud expert.
Exactly. And frameworks like Lithops help there too. It's cloud-agnostic, works on AWS, Azure, Google Cloud, so you avoid vendor lock-in. It lets engineers run their existing Python code, stuff written for one machine, at massive scale across these clouds. It simplifies things massively, lowering the barrier to entry by handling the deployment to serverless functions transparently.
That sounds incredibly useful for getting started fast. But you mentioned serverless functions are often stateless. They don't remember things between runs. So many ML algorithms, especially when distributed, need to share information, right? How do these stateless functions manage that shared state?
Yes. That's where it gets really clever. Joyless functions aren't directly addressable on the network, so they can't just talk to each other easily. Lithops gets around this using a special multiprocessing module. Instead of local memory, which disappears, it stores shared values in what's called disaggregated memory. Specifically, it uses a Redis instance, a fast in-memory data store.
Redis. Okay, no Redis, so it's like a shared scratchpad.
Pretty much, yeah. A very fast one. And this lets you port stateful algorithms, things like k-means clustering or logistic regression to serverless with minimal changes to the code. In k-means, for instance, the different workers need to update and grab the latest cluster centers, the centroids, after each calculation round. Lithops handles that communication using Redis.
Okay, so Redis acts as the central point. Does that lead to different ways of managing access, different strategies?
It does, and there are trade-offs. We looked into implementations using both lock-based and lock-free designs for k-means. The lock-based way uses one central copy of the data. Functions need to acquire a lock to access it, preventing clashes. It guarantees correctness, but the locking adds overhead, slows things down.
Right, waiting for locks.
Exactly. The lock-free way is different. It gives every worker its own copy in the shared state. No direct conflicts, no waiting for logs, so individual updates can be faster. But then you have an aggregation step. One worker has to combine all those individual copies, and that takes longer because there's just more data to process.
Okay, so which one is better?
It depends. Our sources found lock-free was maybe a bit quicker for fewer clusters, say under 50. But as the number of clusters grows, that aggregation bottleneck in lock-free makes the lock-based approach actually faster.
So it's that classic engineering choice. No single best way. You have to pick based on your specific workload, really highlights the nuances developers deal with.
Precisely. It's all about optimizing for your specific context.
Okay, so we've seen how serverless can scale AI. But power without security, that's risky. Which brings us to MLC Ops.
Wow.
We know DevOps evolves into DevSecOps. What does this look like for AI? Why a separate term, MLC Ops?
Yeah, it's a good question. If you think about it, ML systems have a fundamentally different threat surface than traditional software. DevSecOps handles things like injection flaws, bad configurations, known stuff. But AI, it faces unique attacks. Data poisoning, where bad data corrupts the training. Adversarial inputs designed to fool the model theft. Privacy attacks like model inversion trying to extract training data.
Wow, okay. Different kinds of threats entirely.
Exactly. So MLC Ops is crucial because it embeds security throughout the entire MLOps lifecycle, from planning, data engineering, training, all the way to deployment and monitoring. 9 core stages. It's about being proactive, identifying these specific AI risks early, and making security everyone's job, not just an afterthought.
So it's securing the data, the model, the whole pipeline, not just the code. Can you give a quick example? A threat specific to one stage.
Sure. Take data engineering. Data poisoning is a big one there. An attacker slips bad data into your training set, maybe forge spam examples, making your spam filter useless. Or worse, or later at model serving, an attacker could flood your API with complex requests, causing an output integrity attack, degrading performance, or causing denial of service. And AI supply chain attacks are everywhere, potentially compromising third-party libraries, frameworks, even the pre-trained models you might build upon. It's like teaching your AI bad habits from the start.
That paints a pretty stark picture. So given AI is getting into critical areas, how are governments and organizations reacting? What about regulations?
Well, that's a key point, governance. We're seeing regulations emerge globally. The EU's AI Act, the U.S. Executive Order 12110, they're generally taking a risk-based approach, meaning higher-risk applications, critical infrastructure, healthcare face much stricter rules than, say, a recommendation engine.
Makes sense.
And the priorities are pretty consistent. Safety, ethics, protecting rights like privacy and non-discrimination, and crucially, promoting transparency and explainability. Businesses need to be able to explain how their AI makes decisions. That builds trust.
Right, transparency. Especially with model behavior and data privacy, that seems vital. Okay, so with these threats and rules, what are the practical security strategies organizations should actually be doing now to protect their AI in the cloud?
You definitely need robust, layered strategies. First, model encryption and access control. Encrypt your models, tightly control who gets the keys. Strong authentication, clear roles, prevent that model theft.
Basic hygiene almost, but critical.
Absolutely. Second, data governance and verification. You need strict practices. Carefully select, verify, clean your training data. Avoid untrusted sources like random web scraping or crowdsourcing if possible. That's your main shield against data poisoning. And third, we're seeing confidential AI models emerge. These run in special trusted computing environments, hardware-level protection, basically, often with third-party validation. An extra layer of security.
Multi-layered defense, it sounds like. Are there tools to help implement this, maybe open source ones?
Yes, definitely. Open source is playing a big role. Tools like SigStore let you cryptographically sign models, protecting against supply chain attacks, ensuring they haven't been tampered with. There's OpenSSF Scorecard, which assesses the security health of projects, including ML ones. And SLSA supply chain levels for software artifacts helps track where models came from, their integrity. Really useful for debugging issues like bias or injection. These adapt traditional security for ML's unique needs.
Okay, that's helpful. We've covered the power, the necessity of security.
Yeah.
But for many, the elephant in the room is cost. Where do the bills rack up when running AI in the cloud?
Oh, cost is huge. And it's interesting how many things add up. The biggest driver, often compute. Especially those high-end GPUs, NVIDIA A100s, H100s, they can be like $3 to $5 an hour on demand.
That's per hour. Wow.
Yeah. Then storage, petabytes of raw data, processed data, augmented data for training, model weights, checkpoints, logs. It adds up fast. Network costs, too, especially getting data out of the cloud. Egress fees can be around, say, 8 to 12 cents per gigabyte.
Yeah.
Doesn't sound like much, but it accumulates. Even managed AI services, Google Vertex AI, AWS SageMaker, they seem convenient, but pay-as-you-go can bite you with aggressive auto-scaling or notebooks left running idly. And don't forget hidden costs, experimentation, monitoring for model drift, retraining.
So it sounds like costs can really spiral if you're not watching closely. How can organizations optimize? How do you keep budgets sane without killing performance or innovation?
There are definitely strategies. At the infrastructure level, first, be smart about GPUs, TPUs. Match the hardware to the actual need. Not every model needs the absolute top-end chip. Use spot instances or preemptible VMs for training jobs that can handle interruptions. You can save like 60–90% off on-demand prices. Just need good checkpointing, saving progress often.
Right. Save progress, restart if it gets interrupted.
Exactly. And configure auto-scaling properly. Sensible min-max limits, cooldown periods. Use storage tiering, keep active data accessible, move older stuff to cheaper archive storage.
Makes sense. What about the models themselves? Can we optimize there?
Absolutely. At the model level, techniques like model compression are key. Things like pruning, removing unimportant bits of the model. Quantization, using lower precision numbers, saves memory and compute. Knowledge distillation, training a smaller model to mimic a bigger one, all reduce size and resource needs.
Shrinking the model to make it cheaper to run.
Pretty much. Also, choose efficient architectures from the start models, like MobileNet or TinyBert, designed for efficiency. Use batching for inference group requests together for better throughput, and leverage transfer learning, fine-tune existing pre-trained models instead of training from scratch. Saves a ton of time and compute.
So it really is about being smart right from the design phase, not just throwing hardware at it later.
Exactly right. And finally, there's operational optimization. Efficient CI/CD pipelines for ML use caching, track changes smartly to avoid unnecessary full retraining. Set up automated monitoring and alerts for resources. Use catch idle resources or bad scaling configs early. Use cost allocation and tagging to see who is spending what. Set budget controls. And ultimately, embrace FinOps, make cost awareness part of the engineering culture.
What a fantastic journey through AI in the cloud. We've touched on serverless, making things accessible, the absolute necessity of MLC Ops for security against these new threats, and those crucial strategies for keeping cloud costs manageable. The future's complex, no doubt, but with the right approach, powerful and secure AI is achievable. This has been really insightful, thank you. We hope this gives you, our listener, a clearer map for navigating the AI landscape. And before we sign off, just a reminder that this deep dive was brought to you by Stonefly. They really understand data needs in today's world. They're offering a 100 TB immutable and air-gapped SSO NAS that's secure isolated storage for an incredible $8,995. A great way to protect critical data. You can find out more at stonefly.com. So, as we wrapped up, here's something to think about. AI models learn and evolve constantly. How could we design systems that don't just detect attacks, but actually learn to defend themselves against threats they've never seen before? Mimicking AI's own adaptability for defense. Something to ponder until next time.